Hello and welcome. This is EDEXCEL A-Level Pure Maths 1 October 2021, and the first question is factor theorem. So you must know that f of a equals 0 implies that x minus a is a factor. If I put it in green, it means you need to know it. So let's test this. Let's use a is equal to 1. So f of 1 is equal to, in this case, a times 1 cubed plus 10 times 1 squared minus 3a times 1 minus 4. And that is equal to 0 because 1 is a factor. And that is going to give us a plus 10 minus 3a minus 4 equals 0, which is going to give us minus 2a plus 6 is equal to 0. So therefore 2a equals 6, so a equals 3. Question 2, you need to complete the square. So in order for us to do that, I would write x. I would take this value here, minus 4, I'd half it to get minus 2. And I would write squared, and then I'd always take away that value minus 2 again, squared, and we've also got plus 5 on the end. And this is f of x. So simplifying that is going to give me x minus 2 all squared. And this is going to give me 4, so take 4 and plus 5 gives you plus 1. And it says the curve with the equation y equals f of x meets the y-axis at the point P, and it has a minimum turning point at Q. So let's just quickly give it a sketch of what the graph is going to look like. Well, the turning point is the solution to this bracket. So x equals 2 would make that bracket 0, and that's the smallest we could possibly make f of x because that bracket is squared, so I can't make it any smaller than 0. And that would therefore give me 2 there, and if that bracket was 0, then plus 1 would give me just 1 for the value of f of x. So that is the coordinate 2, 1. And where does it cross the y-axis? Well, that's the y-intercept. If we look at the original equation, we're adding on 5. So we're going to cross there at 5. So therefore P is the coordinate 0, 5, and Q is the coordinate 2, 1. Right, question 3, we've got a sequence and we need to show this particular quadratic is formed when we need to add the first, second and third terms. So let's first find u1. Well, that's nice and easy, that's given to us, it's 2. And then u2, other than being a fantastic Irish band, is found by subbing in u1 into this equation. So I get k minus 24 over 2 because that's u1, and that gives me k minus 12. So then u3, I need to sub in the last expression which we obtained, which was k minus 12. So it's k minus 24 over k minus 12. Okay, now what do we need to do? We need to add these and set it equal to 0. So I'm going to have 2 plus 2 lots of u2 is going to be 2k minus 24, just timesing u2 by 2. And then I'm adding on k, and I'm also then taking away 24 over k minus 12, because that's u3. Right, so I'm going to get 3k minus 22 just by simplifying this part, and I've still got this minus 24 over k minus 12, and all of this equals 0, by the way. Okay, so what I'm going to do now is I'm going to multiply every term by this k minus 12. So I'm going to get 3k, k minus 12. I'm going to get 22, k minus 12, and that multiplying by k minus 12 is going to cancel that denominator, and it's also going to multiply by 0 on the right hand side and leave us with 0. Multiplying out the brackets, I get 3k squared minus 36k. I get minus 22k, and I'm going to get, right, time for calculator, 22 times 12, that's what it's there for, 264. And that's going to be positive because you're doing a negative times a negative, so plus 264 minus 24 equals 0. And this is going to give me 3k squared, and I'm going to get minus 58k, and I'm going to get here plus 240 equals 0. And that is what we've been asked to find. Thank God for that. Right, find the value of k. So I'm just going to solve that equation. It's 2 marks. So at A level, I can just literally go straight to my calculator, and I can go into the old equation function. It's a polynomial. It's degree 2 because it's a quadratic, and it's 3 minus 58 plus 264. Sorry, 200 and what am I doing? Sorry, 3k squared minus 58x and then 240. Right, so I'm going to get x equals, or this, sorry, k equals 40 over 3, and I bet the other one's going to be, k equals 6. I've got to choose the correct one. Ah, there it is. K is an integer. I knew there'd be something like that, which means I can eliminate this because k is an integer. It does say give reasons for your answer, so I need to write this down to make sure I get the mark, as k is an integer. And it says find the value of u3. Well, u3 we've already worked out was k minus 24, k minus 12. If k is 6, then this is 6 minus 24 over 6 minus 12. So that is 6. Whoops, let's go back over here. That is 6 minus 24 over 6 minus 12. That gives me 10. Okay, question number 4. Essentially what we need to do is we need to differentiate this, because as soon as you see the word turning point, you know you need to set the derivative equal to 0. So let's first off differentiate that. So the function was x squared plus ln of 2x squared minus 4x plus 5, I believe. Just double check that. Yep. And the first part to differentiate, that's fairly straightforward. We just drop the power down, and then we raise the power down by 1. The next part I'm going to have to use a substitution using the chain rule. So normally, well, ln of u, ln of anything, would differentiate to 1 over u. Then we multiply by the derivative of u, so u dash. So ln here of this would differentiate to 1 over inside the bracket, but then we need to multiply by the derivative of that bracket, which is 4x minus 4. So we are looking to simplify this as much as possible and set it equal to 0 because we're trying to find the turning point. So let's make it into one whole fraction. So I multiply 2x by 2x squared minus 4x plus 5, because then I can also divide it by the same thing to cancel out and leave you 2x. So I'm going to be dividing it by 2x squared minus 4x plus 5 as well. And I've also got this 4x minus 4 over this 2x squared minus 4x plus 5, and that equals 0. Okay, I'm going to expand out the brackets, and I'm going to get 4x cubed minus 8x squared plus 10x plus 4x, which makes 14x, and m minus 4, and that's all over 2x squared minus 4x plus 5, that equals 0. Now whenever I want a fraction to equal 0, I only need to look at the numerator, because the denominator you can just multiply to that side times it by the 0, so it'll cancel. And I can also divide this by 2 on top as well, and I think that's going to give me what I need. That's equal to 0. I think that is what we're looking for. Yes, it is. Perfect. Okay, now we are looking at this iterative formula, and it says is used to find an approximation for alpha, starting with x1 equals 0.3. Calculate, giving you answer to 4 decimal places, the value of x2. Okay, so we're going to need our calculator here. Now, my top tip for this is start off by putting in x1, press equals, and then type into your calculator the function, which in this case is 1 over 7, open brackets, 2 plus, and then whenever you see an x to the n, you just type the answer button, and that will use the previous answer, which we set to be 0.3. And then minus 2, again answer, and then cubed. And this is really useful because you can press equals, and that will give you your x2 value, which is 0.3294. 0.3294. And then if you press it again, you'll get x3. And then if you press it again, you'll get x4, which is what you've been asked to find, which is 0.3398. And then it says, by using a suitable interval and a suitable function that should be stated, show that alpha is this to 3 decimal places. Okay. Well, alpha is the solution to this equation, so we need to show that it changes sign when you sub it in, when you sub a little bit below into that function and a little bit above that function, and that function itself is the f dash of x, which we found. So I'm going to sub in. I'm going to sub into f dash of x, a little bit below this, so 0.3405, 0.3405, and I'm going to sub in a little bit above that, which is 0.415. Those, when I say a little bit above, I mean it's specifically the lower bound and the upper bound when you round to three decimal places. So if I sub those into my calculator, so I'm just going to have to check what the function was. Yeah, so it's 2 lots of 0.405 cubed, and then minus 4 lots of 0.3405 squared, and then plus 7 lots of 0.3405, and then minus 2, and that should give you something, okay, negative and very close to 0. That's good. So that is minus 1.305 times 10 to the negative 3. And then let's go back to our calculator and just change these to 1/5s. And hopefully we will get a positive number. Fingers crossed. Very close to 0. Yes, very good. So 3.66 times 10 to the 3, minus 3, sorry. And you can say that as there is a change of sign and f dash of x is continuous, alpha is equal to 0.34123 decimal places. Question 5. We have some sort of compound interest going on here. So it says the third year. So the first year you have 20,000, and then the second year you need to multiply that by 8% increase, and then the third year you do that again. So it's multiplying by 1.08 squared. And that's going to give you 23328 as expected. And then the next time, the first time it exceeds 65,000. So I want this, and I'm going to call it n-1 because the number of years is actually 1 less than the number you get. For example, here we need to work out the year 3, we had to use 2. And I want that to be greater than 65,000. Make sure you use the inequality, don't use the equal sign because you will lose marks. So dividing through by 65,000, oh sorry, 20,000 divided by 65,000 divided by 20,000, we get 3.25. And then I can take logs of both sides, and what that will do is allow the power to come down, and then I can divide through, so this will tell me that n-1 is greater than log, whoops, I didn't take logs of both sides even though I said I was going to. So log 3.25 over log 1.08, and this gives me I can use luns just rather than logs. It's the same thing, just different bases. And it's going to be 15.3. So n has got to be greater than 16.3, which means that n will equal 17, because it has to be a whole number for the years. Find the total profit for the first 20 years of trading. Giving your answer to the nearest 1,000. The total profit, okay, so we have to use the summation formula for the geometric sequence, which is, you do get this in your formula booklet, and it is a, open brackets, 1 minus r to the power of n, close brackets, all over 1 minus r. So in this case, we have the starting value is this, 20,000, That's the first term. And then we do 1 minus 1.08 because r is the increase, the geometric increase. And we're doing 20 years. And we're all over 1 minus 1.08. And let's type that into our calculator. 20,000, 1 minus 1.08 to the power of 20. Whoops, just press equals there, and then divide that by 1 minus 1.08. And we're going to get, okay, great. So 915,239. I think that should be fine. Excellent. Okay, vectors. So I know that if I want to get from A to C, I can do that by going A to B plus B to C. And I can therefore add these two vectors together. So adding the i's up is going to give me minus 2i. Adding the j's up is going to give me minus 3j. And adding the k's is going to give me minus k. Okay, now I've been asked to show that the cosine of A, B, C, so this angle in here. Alright, so I'm going to have to use the cosine rule for this. And you need to know the cosine rule, and that's a squared plus b squared minus 2b c cosine, sorry, what am I saying? A squared is equal to b squared plus c squared minus 2bc cosine capital A. So in this case, this is the angle I'm looking for, so that's the capital A. So therefore the little a is the one opposite it, and these two are the b's and the c's. Because that essentially is the capital A, is the angle I'm trying to find. So let's rearrange this equation so that cosine is the subject. So I'm going to add the cosine, the 2bc cosine A to the left side, plus a squared equals b squared plus c squared. And then I'm going to minus the a squared to the other side, like this. And then I'm going to divide through by the 2bc. Okay, so with that being said, what I'll need to do is I'll need to work out the magnitudes of each of these ones. So the b, for example, up here, which I'm going to use as b, is actually b to c, and b to c is 1, 1, 4. So I know the distance of that is the square root of 1 squared plus 1 squared plus 4 squared, which is equal to the square root of 18. And the little c that I'm going to use is actually a to b, which is minus 3, minus 4, minus 5. And I know if I square all of these values, doesn't matter about the negative because they're going to get squared. That's going to be the square root of 50. And next, the little a I need to know as well, and that is a to c, which we've already worked out, which is minus 2, minus 3, minus 1. I'll square those to get the actual distance again, so that will be 2 squared plus 3 squared plus 1 squared, which is the square root of 14. Okay, now I can sub these into my formula. So when I square, because they're roots, they're just going to be the value of those roots. So b squared is 18, c squared is 50, and a squared is 14. And I'm dividing that by 2 times b times c, and b and c are 18 and 50. So the square root of 50 and the square root of 18. Okay, I could put that into my calculator, but it does say show that, so I might just do a few calculations here. So that's 68 minus 14, which is 54, which is a multiple of 9, so that's good. And this is 2 lots of root 25 root 2, that's root 50, and root 9 root 2, which is 18. And so root 25 is 5, obviously, and root 9 is 3, and root 2 times root 2 is 2. So that's helpful. Oh, whoopsie, that's 54. So we are going to, yeah, that's going to simplify down to 9 over 10, because you can take out a factor of 6 off the top and 6 off the bottom to give you 9 over 10. Fantastic. Okay, how are we doing? Circles, find the coordinates of the center of the circle. So we need to do completing the square here. So we've got the x, let's take the x value, the half of that is minus 5 squared, take away 5 squared, which is 25. And the y's, we're going to have y and take this, half it, is 2, so plus 2 all squared, and then take away 2 squared, which is 4. And then we've got plus 11 equals 0. So this is x minus 5 squared plus y plus 2 squared, and minus 29 plus 11 is minus 18. So move it to the other side is 18. So the center of the circle is the point 5 minus 2. It's always the solution of these brackets. It's whatever makes these brackets 0. And the radius is the square root of the right hand side. And it says simplified surd. So that is root 9 root 2. So that's 3 root 2. Classic question this. That line is a tangent to the circle. Give the possible values of k. Okay, so what you need to do is you need to substitute into the line equation, sorry, the circle equation. I'm going to use this one rather than this completing the square one, because I just find it slightly easier. And I'm going to sub in this. So I'm going to replace all the y's with that 3x plus k. So I'm going to get x squared plus, not y anymore, that's 3x plus k squared. I'm going to get minus 10x, and I'm going to get plus 4 lots of 3x plus k, and I'm going to get plus 11, and that equals 0. So I'm going to expand that out. I'm going to get x squared, I'm going to get 9x squared, I'm going to get 3x times k and another 3x times k, which is 6x times k, and I'm going to get k squared. So that all comes from expanding this like double bracket here. Next I've got minus 10x, and here I've got plus 12x plus 4k plus 11 equals 0. And now what I'm going to do is I'm going to essentially pair these up, not pair these up, but I'm going to look at the x squareds, the x's, and the constant terms. So let's look, how many x squareds have we got? We've got 10. Great, so 10x squared. And how many x's have we got? We've got 6k there, and we've got minus 10 plus 12, so that's plus 2. So we've got 6k plus 2 x's. And what about the c's, the constant terms? Well, k is a constant, so we've got k squared, and we've got 4k, and we've got plus 11. Okay, so now I've put them into nice, neat quadratic form. And because I know that the question tells me that it is a tangent, the line, it means that the discriminant is equal to 0. So the b squared minus the 4ac equals 0, because the tangent only cuts once, and that means there's only one solution to this quadratic. So now let's use that. The b is the 6k plus 2, because the b is the x term of the quadratic, and take away 4. The a is the x squared term, and the c is the constant term. And that equals 0 because we want the discriminant to equal 0. Yes, oops, that needs to be a squared. Okay, multiplying out that double bracket gives me 36k squared plus 6 times 2 is 12, and there are 2 of those, so it'll be 24k, and plus 4. And then I'm timesing by 40 essentially that bracket on the right, so I'm going to get minus 40 k squared minus 160k, and I'm also going to get minus 440 equals 0. Okay, and moving on, we are going to look at the x squared, the k squared, so we've got minus 4k squared. We've got minus 136k, and we've also got minus 36 equals 0. Let's just divide everything by minus 4, because that just looks ugly like this. So that's 25 plus 9, which is 34k. And dividing that by 4 is 109 equals 0. Okay, let's put that into our calculator because that looks horrid. Whoops, equation, polynomial, quadratic, 134, 109, go. Okay, there's 2 solutions. There's going to be 2 solutions, but does K say, what does K say? Find the possible values. Fantastic. 2 solutions. And are these 2 the same? Yeah, oops, whoopsie. They are, so it's minus 17 plus or minus. So K is equal to minus 17 plus or minus 6 root 5. Great. Job done. Question number 8. So a scientist is studying the growth of 2 different populations of bacteria. So let's highlight the key information. And that is the formula which we're going to use. T is in hours, so that's quite important. There's 1,000 at the start, and after 5 hours, the population doubles. Okay, so then we need to complete a equation for the model. So let's do that. So I'm going to use the model which was n equals a e to the k t, and I know that there are 1,000 when the time is 0, because they said initially there was 1,000, which tells us that a is equal to 1,000. I also know that there were 2,000 because it said it doubled the population, and a we said is 1,000, and that was after 5 when t is 5, so 5 times by the k. Dividing both sides by 1,000 gives me 2 equals e to the 5k. Taking the natural logarithm of both sides means that we get ln 2 is equal to 5k, which means that ln 2 is equal to 1/5. K is equal to 1/5 ln 2. Now, it actually asks us to find the complete equation for the model. So I'm going to have to write that n is equal to 1,000 e to the k, which is 1/5 ln 2t. And that's my complete equation for the model. The next question says hence find the rate. So that's again needs to be highlighted because the rate means we need to differentiate our function after 8 hours. Okay, so let's differentiate our function first to find the rate of change with respect to time. So differentiating that, well, when I differentiate an e function, I need to multiply by the derivative of the power. So the derivative of this power is just a fifth ln 2. So I'm going to get 100 multiplied by a fifth ln 2, and then e to the 1/5 ln 2 t stays the same. And we need to work out what happens when t equals 8. So I'm going to substitute in here t equals 8. So it's going to be 1000 times a fifth, that's 200. So it's going to be 200 ln 2 e to the 1/5 ln 2 times by 8. Putting that in brackets just so it's nice and clear. Okay, so that needs to go into our calculator, and that will give us, let's just type it in now, so 200, and then I would write ln 2, close brackets, and then I would write e to the power of, and then 1/5 is 0.2, and then ln 2, close the bracket, and multiply that by 8. And we'll get 420. So 420 seems correct to me. Great. Question part C. We now have another model that looks like this, where the k is the same value as part A, and t is again hours, and it says for us to show when the two different populations are the same. So we need to set one of them, we'd set each of them equal to each other. So that one is 500 e to the 1.4k. And what you're doing there, you can go away, thank you. Okay, so let's set them equal to. So the first one was 1000 e to the 1/5 ln 2 t, and that's equal to 500 e to the 1.4, and the k value is the same, so that is 1/5 ln 2 capital T. Okay, so first thing I would do is I would divide both sides by 500 to get 2 on this side, and then I would divide both sides by this e to the 1/5 ln t, 1/5 ln 2t. So I would get 2 is equal to e to the 1.4 times 1/5 ln 2t divided by e to the 1/5 ln 2t. Okay, so just to run through what I did there, I divided both sides by 500 first, and then I divided both sides by e to the 1/5 ln 2 capital T. Okay, so now we've got e divided by e. So in this case, what we do is we subtract the powers. So we've got 1/5 times 1.4, which is 0.28. So we've got 0.28 ln 2t minus 0.2 is 1/5 ln 2t, and all that is e to the power of, and all of that equals 2. Because again, when we divide e's, we're just going to subtract the two powers to combine them. So we're going to end up with 2 is equal to e to the 0.08 ln 2t. We're going to take the natural logarithm of both sides, and that's going to cancel and bring the power down. And then we're going to divide through by 0.08 ln 2. So I am hoping that we will end up with a feasible answer when I do ln2, close brackets, all over 0.08 ln2. And I get an answer of 12.5 hours. Make sure you put the units in as well. Okay, question 9, you need to use a partial fraction. So what I'm going to do is I'm going to set this 50x squared plus 38x plus 9 all over 5x plus 2 all squared, and then 1 minus 2x, and I'm going to set that equivalent to a over 5x plus 2 plus b over 5x plus 2 all squared, and plus c 1 minus 2x, sorry. Multiply through by this denominator here, so multiply every side by those terms there. Cancels the denominator on the left hand side to leave you with this, and it's going to leave me with a. There's going to be one 5x plus 2 left over because only one of them has been cancelled. And over here there's going to be no 5x plus 2s because both of them have been cancelled. And over here we're going to be left with 5x minus 2, sorry, plus 2 all squared. I'm then going to let x equal a half because it's the solution to the 1 minus 2x bracket. And that is going to give us, when I sub into the left hand side here, 81 over 2, and when I sub it into the right hand side, this a bracket is going to cancel, so is this b1, and we're left with a c1, and that will come out as 81 over 4, and that tells me that c must equal 2. Next I'm going to let x equal minus 2 over 5. When I sub that into the left hand side, I end up with, if I can remember, no I can't, I might have to type it in, so 50 minus 0.4 all squared, and then plus 38 times minus 0.4, and then plus 9 over 5, great. And then if I sub it in, the a bracket cancels and the c bracket cancels, the b bracket remains, and I believe that one was also 9 over 5. So therefore b is equal to 1. Yes. And now in order to work out the final one, I just set x equal to anything I like, so 0 is the easiest. So the left hand side becomes 9. We end up with 2 and 1 a, which is 2 times a, so 2a. And then over here we've got 1b, which is just 1. And here we've got 2 squared c, so 2 squared is 4, so 4c, and c is 2, so 8. And this is enough to show that a is equal to 0. Okay, next what we need to do is you need to expand it using the binomial up to the squared term. So the binomial expansion is right there, that's handy. Let's just pick that up and move it over here. And let's start by expanding the first term. Well, a is 0 for the first one, so we don't need to do that at all. The second one, b is 1. So that is 1 over 5x plus 2 all squared, which I could write as 5x plus 2 to the minus 2. Whenever I use the binomial expansion, I need the constant term to be 1, so I'm going to divide through by 2. So I get 5 over 2x plus 1. And when I take out a factor of 2, I also need to take out the power with it. So it's 2 to the minus 2. Okay, so what is this equal to? Well, I've got 2 to the minus 2 is a quarter. I've got 1. I've got nx, which is n is minus 2, and x is 5 over 2x. I've got here n again is minus 2, n minus 1 is minus 3, and then I've got 5 over 2 x squared, all over 2. And we don't need to go any further than x squared because that is how far we've been asked to go. So multiplying through, 1 times a quarter is a quarter. The 2's will cancel, the negative will stay, there's a 5 there, so that's minus 5, and then also there's a quarter there, so minus 5 over 4x. Then here the 2's will cancel there, we've got a 3, we've got a 5 squared which is 25, so that makes 75, and we've got 2 squared on the bottom which is 4, times by the 4 is 16. So we've got 16 on the bottom, 75 on top, x squared, and that is a positive because the 2 negatives will cancel. Okay, great, that's that one done. But now I've got to do the other one, which was c over 1 minus 2x, and c is 2. So that is 2 over 1 minus 2x, which is the same as 2 lots of 1 minus 2x to the power of minus 1. And using the same binomial expansion, which I'll just leave up there, we will get 2 lots of 1, and then nx is plus minus 1 minus 2x, and then we have the next one is n, which is minus 1, n minus 1, which is minus 2, and x squared is going to be minus 2x all squared, and that's all over 2. And then we have, let's multiply this out. So we're going to get 2 times 1 is 2. We're going to get 2 negatives, make a positive. We've got 2 and another 2, so that's 4x. And over here we've got a negative, and a negative squared, so that's going to be positive. And we've got these 2's will cancel. We've got 2 squared is 4, times 4 is 8x squared. And then all that's left to do is just to add these 2 together. So that's this one and that's this one. So I'm going to add the 2 together to get that the function is roughly equivalent to 2 plus a quarter is 9 over 4. 4 minus 5 over 4, well 4 is 16 over 4, so 16, so it's 11, so it's 11 over 4 x. And then here we're going to have, let's calculate to help me out with this one, 75 over 16 plus 8 is 203 over 16 x squared. Okay, I think that is good. Okay. I just missed the final part, and that's the range of values of x, which is this expansion is valid. Okay, so this was good. I just checked the mark scheme. That is all good. And the range that the function is valid. So we need to look at what we've just expanded, and we have just expanded this 5x plus 2, and we've also expanded this 1 minus 2x. And we're told by the that we had to rearrange that, didn't we? Rearrange that to 5 over 2x plus 1. Okay, and we're told that this modulus always needs to be less than 1, and in this case minus 2x modulus always needs to be less than 1. Always needs to be less than 1. So multiplying through, we're going to get x is less than times by 2 divided by 5. So 2 over 5. And over here, the negative we can disregard because it's inside a modulus bracket. So we would get x needs to be less than a half. So they have to be both of those, and because this one is smaller, we need to select this one. So it's going to be less than 0.4 and less than 0.5. So overall, it has to be definitely less than 0.4. Okay, this one we are going to need to use our cosine 2 theta expansions, and you need to know this one, and you also need to know this one, and you also need to know, of course, sine 2 theta as well, which is 2 sine theta cos theta. So those you absolutely need to know. And then what we're going to do is we want to make the top sort of as sine-y as possible. So I'm going to use the sine expansion for cosine 2 theta on the top. And that is because I'm told that it's all going to equal tan. And tan is, of course, sine over cos. And let's make the bottom as sort of cosy as possible. So I'm going to use the cos expansion for this one. And then if we expand that out, I'm going to get 2 sine squared on top. And I'm going to get oops, sorry, I made a mistake there. That should be a -1. It's cos squared -1. That should be a -1. So we get 1 minus 1, that's 0. So that's going to be 2 cos squared theta on the bottom, and we're going to get plus 2 sine cos. I'm going to divide everything by 2. I'm going to factorize, so I get sine on top, open brackets, sine plus cos, and that's all over cos on bottom, sine plus cos, which will cancel and leave me with sine over cos, which is tan. Okay, now classic question that you need to use that identity in order to solve an equation. So normally, if those two blue things were exactly the same, we could set these two things to be exactly the same. But they're not quite, but they're very similar. The only difference with the blue one is that the 2 theta is now turned into a 4x. So therefore, by that logic, a 1 theta will turn into a 2x. So I can set these two things equal to each other, but I just need to replace tan theta with tan 2x. So I get tan 2x is equal to 3 sine 2x. Perfect. So what I'm going to do is I'm going to write that as sine 2x over cos 2x, because I don't really want to use the tan 2x expansion, it's quite messy. And that's going to give me sine 2x is equal to 3 sine 2x cos 2x. I'm then going to set it equal to 0 by moving over this sine 2x. And then I'm going to factorize. I'm always going to factorize rather than dividing through by sine 2x. And I'm going to get this. Great. Now, where are the solutions? Well, there's one solution here if sine 2x equals 0, and there's one solution here if cos 2x equals a third. Okay, now let's use our calculators here. I need to put it into degree mode because it is degrees, and it's asking me between 0 and 180. not equal to 0 or 180 as well, which is quite interesting. So 0 to 180. I'm dealing with two x's here, so I'm going to change that to 0 to 360. I'm going to do the sine one first. I just need to go to setup. I need to change my angles into degrees. And I need to do sine to the -1 of 0. And of course that gives me 0, but that's not a solution. The next one along would be 180 minus that answer, which would be 180. And then the one after that, you just add 360 to both of these two to find the next ones. So 360 and then add 360 to that would be 540. Now, already, if we're looking at the range here, I can eliminate 0 because it's not equal to 0, and I can eliminate 360 and I can eliminate that one as well. So this is the only solution for 2x. So therefore half that, I get 90. Now let's look at cos. Let's go for our calculator, and let's do cos to the -1 of a third, and I get 70.5. So 2x is equal to 70.5. The next solution for cos is 360 minus, and that's 289.5. Okay, and then after that, what I would do is I would add 360 to both of these two. I know they're going to be too big though, because adding 360 to those numbers is going to take us past the 360 mark anyway. So divide those by 2, I'm going to get 35.3, and divide that by 2, I'm going to get 144.7. So those are our solutions. It says to one decimal place where appropriate. So that looks good to me. Let me just check the solutions. Bosh. Okay, trapezium rule. You're given that in your formula booklet, and it is h, which in this case is the gap between these x's, which is 0.5. So it's 0.5 over 2, open bracket, the first point, which is 0.4805, plus 2 lots of all the ones in the middle, so 0.8396, plus 1.2069, plus 1.5694, and then plus the end point individually, which is that, close bracket. So let's put that into our calculator. 0.5 over 2, open bracket, 0.4805 plus 2 lots of 0.8396, 0.8396 plus 1.2069 plus 1.5694, close brackets, plus 1.9218, and we get three significant figures, 2.41. So 2.41. Next part asks us to integrate this function. So we're going to have to use integration by parts whenever you're integrating a ln function. So I'm integrating ln of x squared between 4 and 2. Now the way that we do this is we select u always to equal the ln part, because that's the part we're going to differentiate, and differentiating lns is easy than integrating. And the dv part, we're going to use just 1. So differentiating this, I'm going to need to use the chain rule. So I'm going to bring the 2 down to the front, keep the bracket the same, drop the power down by 1, and then I'm going to multiply it by the derivative of the bracket, which is 1 over x. So multiplying through by 1 over x is going to give me this. And when I integrate this, it just integrates up to x. So using the formula that I've put down at the top there, u times v is x, open brackets, ln x squared, minus the integral of v, which is x, times by 2 lots of ln x to the power of 1 over x. Okay, great. So this is going to cancel with that, which is going to be very helpful. So I just need to integrate 2 ln x. Okay, so I'm going to do that below. The integral of 2 ln x, we'll have to use integration by parts again. So I'm going to let u equal to the, let's just make it equal to ln x, and let's make dv by dx equal to 2. Okay, so du by dx will equal 1 over x, and v would equal 2x. So using integration by parts, we times u by v, so I get 2x ln x, and I take away the integral of the bottom 2 times together, which is just 2. So therefore, we get 2x ln x minus 2x. Okay, so that needs to go up over here. So now the integral which I'm trying to work out is between 4 and 2, and I've already worked out it's this x ln x squared, and I'm taking away that new integral which I've just done, which is 2x ln x, and because I'm taking it away and there's also a takeaway sign there, it's going to be plus 2x. Okay, now what I need to do is I need to evaluate that. So I need to sub in 4, and I'm going to get 4 ln 4 squared minus 8 ln 4 plus 8. And I'm going to take away, when I sub in 2, I'm going to get 2 ln 2 squared minus 4 ln 2. Oh no, not minus, because I'm taking it away. So it's a plus. And I'm taking away, again, 2 times 2, which is 4. Okay, now what I'm going to do, because if I look at the answer, it wants it in terms of ln 2's only. So I need to get rid of these ln 4. So I'm going to do a substitution. So ln 4 is equal to ln 2 squared, which is 2 ln 2. So let's replace all the ln 4's with 2 ln 2's. So I'm going to get 4 lots of 2 ln 2. I'm going to get 8 times 2 ln 2. I'm going to get plus 8. I'm going to get minus 2 ln 2 squared plus 4 ln 2 minus 4. Okay, now let's collect like terms. How many ln 2 squareds do I have? Well, this one here I could write as 4 times 2 squared. 4 times 2 squared ln 2 squared, because I can square the 2 inside the bracket and take it out. So that's actually 4 times 4, so that's 16 ln 2 squareds. And I've also got minus 2 ln squareds there as well. So overall I've got 14 ln 2 squareds. So I've got 14 ln 2 squareds. Now let's look at the ln 2's. I've got minus 8 times 2, which is minus 16, and plus 4, so that's minus 12 ln 2's. And the constants, I've got 8 and 4, which is just plus 4. And I think that is done. Okay, I had to grab some more space for this one. There's a lot of text. So you've got a golf ball, and it goes from free all the way to the ground, and we need to work out the quadratic equation which represents this flight. So if it's a quadratic equation, it will be ax squared plus bx plus c. The first thing that we know is that it passes through the y-intercept at 3, so we know that the c value is definitely going to be plus 3. We also know that it has a vertical it reaches maximum vertical height after travelling a horizontal distance of 90. Okay, so therefore there 90 is going to be the max height. And what do we know about the max height? We know that the gradient is 0, so we know that dh by dx, which is equal to 2ax plus b, we know that that is equal to 0 at x equals 90. So subbing in x equals 90 gives me 180a plus b equals 0. Okay, so that's an equation which we'll need to solve. We need another one to solve it because that's going to be simultaneous. You say it is at a vertical height of 27 meters above the ground after traveling a horizontal distance of 120. So therefore we know that the height, which is the original formula here for h, is 27, and that equals a, and then the x value is 120 squared, and then plus b times by 120, and then plus 3. Okay, so rearranging minus 3 to both sides, so 24 is equal to 120 squared, which 120 squared, which is 14400 a, and then plus 120b. Okay, so now I've got two equations now which I can solve simultaneously. I'm going to do it just by using my calculator because I'm feeling lazy. I'm going to go into equation. I'm going to go into simultaneous. Two unknowns, and we've got 180, we've got 1, and we've got 0. And then we've got down here, we've got 14400, and we've got 120, and that's equal to 24. Okay, so we have x, which is the first, which is the a value, is equal to minus 1 over 300. And then the other one, the y, which is the b value, is equal to 3 over 5. So therefore, the function h is equal to minus 1 over 300 x squared plus 3 over 5x plus 3. So that is the function. Hence, find, according to the model, the maximum height of the ball above the ground. Well, I know that the height is equal to this, and I know that the vertical height, the maximum height, happens when it's 90. So I just sub in 90 into this equation to get that value. So let's go back to the calculator. Minus 1 over 300. I need to times that by 90 squared. I need to add on 3/5 times by 90. I need to add on 3. And I should get 30. Great, so 30 meters is the answer there. Make sure you use the units as well. And then the horizontal distance traveled by the ball from when it was first hit to when it hits the ground again. So when it hits the ground again, we need the height to be 0. So I'll need to solve that quadratic equation when it's equal to 0 to get an x value out. So let's go to our quadratic solver on our calculator, and let's solve the polynomial, which is degree 2, which has an x squared coefficient of minus 1 over 300. It has a x coefficient of 0.6, and it has plus 3 there. So you should get one value which is positive, which is 184.8. 184.8. So to the nearest the nearest meter, that is 185 meters. and it says the possible effects of wind or air resistance are two limiting limits on the. Give it another one on the model. You could say that the ground is not likely to be horizontal. So ground is not likely to be completely flat. You could also say that the ball is unlikely to be modelled as a particle. So the ball might spin and it might itself have distance, width and height, for example. Okay, if these parametric equations satisfy this curve, then when I sub in the x values and the y values, then we are going to get them equal to 4. So I'm going to minus 3, and I can write 3 as 3t squared plus 1 over t squared plus 1, and then that all needs to be squared, and then plus the y, which is 4t over t squared plus 1, again all squared. Now hopefully this should equal out to 4, and then we would know that it's correct. Okay, so let's evaluate the top line here. So I'm going to get a t squared minus 3t squared, so that's minus 2t squared, and I'm going to get a 5 minus 3 times 1, which is plus 2, and that's all over t squared plus 1. And here this one is just going to stay the same for now. And then what I can do is I can square out both sides, or square out both terms, should I say. So when I square minus 2t squared plus 2, I need to times it by itself. So I'm going to end up with 4t to the 4. Whoops. 4t to the 4. I am going to end up with a minus 4t squared and another minus 4t squared, so minus 8t squared, and I'm going to end up with plus 4. And when I square the top one of the right term, so when I square this one, I'm going to get 16t squared. So let's add that on, 16t squared. And then when I square the denominators, well, that's just going to be t squared plus 1 all squared like that. Okay, so next that is going to equal, take out a 4, and I'm going to get t to the 4 plus 8t squared plus 1. Nope, sorry, I've taken out a 4, so that should be 2. Oh great, I see where this is going now. And that's t squared plus 1 all squared. So the top line there can actually be factorized to get t squared plus 1 all squared over t squared plus 1 all squared, which is equal to 4, so therefore it is correct. Okay, we are differentiating here. Now, we could use the quotient rule and set u equal to x minus 4 and set v equal to 2 plus root x and go down that road. But I think there is an easier way of doing this, because what I've spotted here is that we could use a type of difference of two squares, because if we look at the numerator and the denominator, they look very similar. So let's imagine if we had 2 plus root x and if we had 2 minus root x, what would come out of that bracket? Well, we would get 2 times 2 is 4. We would get 2 root x and a minus 2x. So that would cancel, and we would get minus x. Okay, so that is very similar to the numerator. So let's rewrite this then as let's rewrite this as x over 4. Sorry, let's rewrite the numerator as 2 plus root x, 2 minus root x, but I need a negative in there just to swap them around so that it does actually become the 4 minus x like it needs to be, rather than the x minus 4 rather than 4 minus x. And let's have the denominator as it is, and then let's cancel them. So that cancels with that. Applying the negative is going to give me root x is going to be positive and minus 2. Okay, great. Now all we need to do is differentiate that. And that's going to be much easier because that is a half x to the minus a half. That's it. So that's 1 over 2 root x. And we are done. Okay, question number 15. Use proof by exhaustion to show that for all n, for n less than or equal to 4, that is true. Okay, so n is a natural number, so n is a whole number basically. It could also be 0. So we have to just try n equals 0, n equals 1, n equals 2, n equals 3, n equals 4. Sorry, it's a natural number and 0 is not a natural number, so it's just these numbers 1, 2, 3 and 4. So when n is 1, we're going to get 2 to the 3, which is equal to 8, which is greater than 3 to the 1, which is equal to 3. So that works. The next one, we're going to get 3 to the 3, which is equal to 27, which is greater than 3 squared, which is 9. Yep, that works. And here we're going to get 3 plus 1 is 4, so 4 cubed is 64, and that is greater than 3 to the 3, which is 27. Yes, that works. And next one we're going to get 5 cubed, which is equal to 125, which is greater than 3 to the 4, which is 81. Okay, so that's proved that those work for all of those values. Now you need a statement here. So you need to say, so for n less than or equal to 4 and n natural number, n plus 1 cubed is greater than 3n. Okay, you have to put a statement. And then it says, given that m cubed plus 5 is odd, use proof by contradiction to show using algebra that m is even. Okay, so you need to bring in the statement. You need a statement to start, which you're going to then negate. So you're going to say let m cubed plus 5 be odd. We're going to say let m cubed plus 5 be odd. Then m is odd. Okay, so let's try this to see if this works. So let m be 2k plus 1, because we're saying that m is odd. Let's then cube it and add 5 to it. Now if I'm going to cube this, I'm going to end up with, let's use the binomial expansion here. So I'm going to have 1, 3, 3 and 1. The 2k needs to be cubed, so that's going to give me 8k cubed times by 1. The next one needs to be squared, so I'm going to get 4k squared, and then I'm just going to get 2k, and then I'm going to get just 1, and the 1s are going to be just 1. So I'm going to end up with 8k cubed plus 4k squared plus 2k plus 1, and I've also got a plus 5. Okay, so this gives this is obviously going to be even, because you can see here that all of the terms are divisible by 2, and I can prove that by just writing a 2 outside. So I'm going to get 2, and I'm going to get 4k cubed plus 2k squared plus k plus 3, and we're going to say that this is even, and we're going to say that's a contradiction because we started by saying that this was going to be odd. Apologies for the pen lagging.